Hi, in this video we are going to introduce a very important concept called the solver space. Let's first open our example file, the sample 30, the zone, the sample 30, the spot logic 1. And you may notice that all of the simulation in all of the previous videos happened in the world transformation space, but based on the MyRB design, we actually designed it in the simulation in the local transformation space so that you can separate it or offset your current simulation to anywhere as you wish. So let's first make an example. Let's first create a curve for simulate a road. Let's move this up a little bit for the control curve and move this right a little bit and convert this to the road and edit the road parameter like the width and bound all of our agents initially inside this road and increase the flow length and the flow orient, make the roads. The road side is actually the point to the center, so that our agents will be walking to the center when the agent is on the side. Let's place our agents and the playback our simulation. You can see that our agent cannot follow the road because there's no any of the logic of the road. Let's just import them by the preset. Here, MyRB, load and save assets, load logic here. And in your MyRB installation place, the program file, the base font MyRB, my preset, and logic here, you can see that there's a follow road logic, and you can just import that follow road. You can see that there are two logic nodes has been created for you to follow the road. If the road is pointed to the left, I go to the left by the rotate as speed at 120. They are the symmetric one with some of the fuzzy logic like the 30. And let's create the priority logic P2. The priority 1 is the avoid each other. And P1, a middle click and drag P2. And P2 should be under P1. So that means our agent can avoid each other firstly and then try to follow the route. Let's play back our simulation. Everything is correct, and you can see that at this time we can create a platforms which we can make our simulation in the local transformation space. Let's create it as a plan like this. Just imagine that this is kind of the battleship or the spacecraft. Now our agent will simulate inside of this space. Let's deplace our agent, and we need to also continue to create a solver space in the knowledge and perception content. Create a solver space, or you can click this button and create a solver space. And parent all of your the scene object to this element, to this node, can make the simulation happen in the local transformation space. You can see that this is a solver space. We can move that around as you wish, and we can firstly parent this platform into this guy, and then the place node MCD space 1, and also the control curve of the road. If you parent the control curve to this space, the other node will be automatically go to this space, so that you can see that all of the element is inside of this space. So we can rotate and move that. Please do not scale that. Scale is not very in the house in the MyRB simulation. You can rotate it as you wish. Just imagine that this is kind of the platform. Let's do some more optimization. Let's just rotate it and move up right a little bit. Let's place our agents. You can see that the simulations can be happening inside of this local transformation correctly. Let's play back, and you can see that everything is fine. So this is really cool. Let's create a bound here and scale this up a little bit, and the bound our agent on the road and see what will happen. Please notice that this bound is actually currently also in the world transformation space, so it will not affect the agent in the simulation solver space. So these two things will be separated. Let's just add a logic bound, color change. And you can see that. Let's just fill the logic in bound and change the color. Set my color to the 2. You can see that our agent will follow the road, but if they enter the bound, nothing happen because the bound is outside of the solver space. But if we just put that to the solver space like this and run the simulation again, you can see that everything is correct now. That is cool. So this is the power of the solver space. And of course you can make 2 solver spaces inside of your scene and separate the simulation. So let's do that. Let's deplace our agent and create another. Let's just duplicate this, place duplicate, and put this outside, Shift P, and the parent that to the regular, or just leave here. Let's create a new solver space. Click this and here, and place the second placement node to the solver space 2. Let's just resume them back, this transformation. This is our default the world transformation, the orientation with the 0. You can see that. And let's create another route. Create a CV curve tool. CV curve tool. And convert this to the road. Wider and flow length longer with this flow orientation to point to the center. And let's run a simulation. You can see that our agents will try to follow the road. Oh, I'm sorry, I needed to put this road into the solver space 2. Oh, I'm sorry. Deplace our agents and put this control curve to the solver space 2. And also we needed to put this placement into that. Please keep everything inside of the solver space 2 and place our agents and run the simulation. You can see that our agent will try to follow the road in the solver space 2. That's cool. And also we can duplicate the bound, Control D. This bound 1 and parent this bound 1 to the solver space 2. And here we need to move this right here, this place. So you can see that there are 2 systems here. Let's duplicate the platform also and parent that to the solver space 2 and resume all to the 0 because there are 2 solver spaces out there at this moment. Let's move this up. And also we can rotate the second solver space as you wish. Let's play back our simulation. You can see that the different agents in different solver space can interact with the different elements, and also it's turned to the yellow because the color logic is working now. You can use the solver space to simulate something in the separated space, for example, different battleship or the spacecraft for achieving whatever the result you want. Okay, this is an introduction for the solver space. Thank you for watching. See you next time.